Hello, and a very warm welcome to Tech Curiosity Stream. It's fantastic to have you here with us today. If you're someone who is always asking how or why, when it comes to technology, then you've definitely found the right place. Our channel is all about peeling back the layers of the digital world, exploring the complex ideas that power our daily lives, and making them simple and easy to understand. I want to take just a quick moment to invite you to join our growing community of curious minds. Please consider hitting that subscribe button. And while you're at it, don't forget to ring that notification bell. Have you ever stopped to think about how your favorite apps seem to talk to each other so seamlessly? How does your weather app know the exact forecast for your location? Or how can you log into a new website using your Google or Facebook account with just a single click? It all feels like magic, doesn't it? As if all these different pieces of software are part of one big, interconnected family, sharing information effortlessly. The secret behind this digital magic has a name, and it's probably something you've heard of but maybe never fully understood. The term is API. Imagine you're at a fancy restaurant, ready to order a delicious meal. You are the user, or in the tech world, you could be an application that needs something. You have a menu in front of you, which lists all the dishes the restaurant offers. This menu is crucial. It tells you exactly what you can order and what you can't. You don't just stand up, walk into the kitchen, and start rummaging through the pots and pans to make your own steak. That would be messy, inefficient, and the chefs would probably kick you out. The kitchen is a complex system with its own rules, processes, and ingredients. This is where our hero, the waiter, comes in. The waiter is your intermediary, your messenger. You look at the menu and you place your order. You might say, "I'll have the grilled salmon with a side of asparagus." The waiter understands your request perfectly, writes it down, and carries that specific instruction back to the kitchen. Think about building something with Lego bricks. When you buy a Lego set, you get a box full of different pieces, various shapes, sizes, and colors. Crucially, all these pieces are designed to connect to each other in a standardized way. The little studs on top of one brick fit perfectly into the tubes on the bottom of another. You don't have to worry about whether a red brick will connect to a blue one. You just know they will fit together seamlessly. This standardized connection point on every Lego brick is like an API. You can build anything you can imagine because all the individual parts are designed from the ground up to be compatible and work together as part of a larger system. Here is one final analogy that really hits home, especially for anyone who has ever traveled internationally. You go from one country to another, and you find that the shape of the power outlets is completely different. Your American plug just won't fit into a European socket. To solve this, you use a universal power adapter. This clever little device sits between your plug and the foreign wall socket. The power adapter acts as the translator or the intermediary. It understands the requirements of both systems and allows them to connect and work together. Let's take a real-world tech example we use all the time, a weather app on your phone. When you open that app, it doesn't magically know the temperature outside. It needs to ask for that information from a specialized weather service. This process of asking is called making an API request. This request isn't just a vague shout into the void of the internet. It's a highly structured message, like a very specific order form. For our weather app, the request would include key pieces of information. First, it would need your location, maybe using the GPS coordinates from your phone. Second, it would specify what kind of data you want. Once the request from your weather app leaves your phone, it zips across the internet to its destination, the API server. This isn't just one computer, it's likely a massive, powerful data center. When your request arrives at the server's first job is to receive and validate the request. It checks if the request is formatted correctly and if the API key provided is valid. The server's software dives into its vast databases of weather information. These databases are enormous, containing constantly updated information from weather stations, satellites, and forecast models all over the globe. The server structures the data with clear labels. It might say, temperature_high, 75 day, Tuesday precipitation_chance, 10%. The single biggest advantage, especially for the people who build the apps and websites we use, is that APIs save an unbelievable amount of time and effort. Instead of building their own secure payment processing system from scratch, a developer can use an API from a company like Stripe or PayPal. This is the power of not reinventing the wheel. APIs allow developers to stand on the shoulders of giants, leveraging existing powerful solutions. This lower barrier to entry fosters competition and innovation, as even small startups can build powerful applications that rival those of large corporations. Beyond just saving time, APIs actively fuel innovation by creating a kind of digital playground for developers and entrepreneurs. A classic example of this is the story of Twitter. In its early days, Twitter's own website and mobile app were quite basic. However, they made their data available through an API. Developers around the world jumped at this opportunity. When Google released the Google Maps API, it didn't just lead to more maps on websites. It spawned entirely new industries. Ride-sharing companies like Uber and Lyft are built on the foundation of mapping APIs. APIs are really the secret ingredient behind the smooth, integrated, and effortless digital experiences we've all come to expect. Think about planning a vacation. In the past, this was a huge chore, but today you can just go to a single travel website, like Expedia or Kayak. On one screen you can search for flights, hotels, and rental cars all at once. When you finish a workout on your Nike Run Club app, it can automatically post your results to your social media feed. That's an API at work. When your smart home app lets you control your Philips Hue lights and your Google Nest thermostat from one place, that's two APIs working together in harmony. Like any powerful tool, APIs come with their own set of risks and challenges. The very thing that makes them so useful also makes them a prime target for malicious actors. Every time a company creates an API, they're basically creating a new door into their house. If that door isn't properly secured, it can become a serious vulnerability. A poorly secured API can be exploited by hackers to gain unauthorized access to a company's databases. They could steal user data like names, email addresses, passwords, or even credit card information. The challenge for developers and companies is that APIs dramatically expand what's known as the attack surface. The first and most fundamental line of defense is all about controlling who can use the API and what they are allowed to do. Think of it like trying to enter a secure building. In the world of APIs, authentication is often handled using API keys. When a developer signs up to use an API, they are issued a unique secret key. Once the security guard has verified your ID, they then need to check what you're allowed to do. This second step is authorization. Companies implement authorization by setting up strict permissions and rules for each API key. This is called the principle of least privilege. Building a secure API isn't a one-time task. It's an ongoing process of vigilance. Companies must constantly monitor their APIs for unusual or malicious behavior. One common technique companies use is called rate limiting. This means setting a limit on how many requests a single API key can make within a certain period. Companies use sophisticated API management platforms and security tools to get a deep analytical view of their API traffic. These tools can automatically flag suspicious activity. Ultimately, robust API security is a layered strategy. It starts with a secure design, is built upon strong authentication and authorization, and is maintained through constant monitoring. As we look toward the horizon, it's clear that the story of APIs is far from over. We are just entering a new and even more exciting chapter. One of the biggest trends shaping this future is the rise of artificial intelligence and machine learning. Imagine APIs that don't just fetch static data, but can provide intelligent insights. Furthermore, the Internet of Things is set to cause an explosion in the number and variety of APIs. Soon, everything from your car and your refrigerator to a city's traffic lights will have an API. This hyperconnectivity, all managed through secure and standardized APIs, will unlock a new level of automation and convenience. So, there you have it. We've journeyed deep into the digital world and pulled back the curtain on one of its most fundamental and powerful secrets: the application programming interface. We started by demystifying the term, learning that an API is simply a messenger, a waiter at a digital restaurant, that allows different software applications to talk to each other. Hopefully, the next time you use an app to order food, check a map, or log in with a single click, You'll have a newfound appreciation for the incredible work these digital messengers are doing behind the scenes. If you found this journey insightful and want to explore more tech mysteries with us, please hit that subscribe button and ring the notification bell. See you in the next video. Until then, stay curious.